Ladies and gentlemen, I wonder if you've been looking at social media or the news or just politics in general recently and just been thinking to yourself, are people getting fucking stupider? Because it does seem there's a lot of stupidity and a lot of weirdness going on recently. And what I want to do in this episode is take that basic sentiment and explore it. And I want to explore it in the Polymath way. I want to look at it scientifically. I don't want to present you guys with personal ramblings or musings or weird gut instincts and biases. I want to try and shine some light on this. I want to try and look at statistics, psychology, neuroanatomy. I want to explore this properly. And if you've actually been listening to this show before, you may notice that my voice is a bit less muffled and shit than it normally is. That's because I got a new mic. I got a Samsung Q2U mic, which I hope you guys are enjoying. I've also starting to record not just using my laptop's voice recorder app, but using Audacity, which I do not fucking love. Audacity is an op, in my opinion. But for you guys, but for the viewers, I will do it. I was originally going to use a Shure SM57 mic, but that's an XLR mic, and I'm a little bit fucking stupid, ladies and gentlemen, and I don't really like dicking around with lots of different adapters and cables and complex technology. I prefer just a simple USB mic, like the Q2, which I can understand. The slight problem with that is that there may be some cheese in my laptop USB port. I really like cheese, and I'm quite a messy eater, and I can understand how, as a consequence of that, there may be a dairy obstruction in my laptop. I think I've excavated the cheese. I think the cheese is gone. But if there are any weird bits and bobs at the recording, it may be because of the lactose inside my computer. So we'll just have to see what happens. But anyway, on to the episode. Is humanity getting dumber? Now, when we look at this, when we answer this question, when we look at it, we're tempted to think about our immediate context and our lived experience. We're tempted to think about what has been happening in the Western world in the past few years. But actually, if we want to answer this question properly, we can't just be looking at that. We need to massively broaden our scope. We need to look at humanity in general, and we need to look at the scope of decades. We need to be asking ourselves, since IQ testing began, what has been happening? What has been the change in that? Have we been getting smarter, and have we been getting data? That doesn't make any sense. Have we been getting smarter or have we been getting dumber? What did I say? Did I say smarter and data? I don't know, guys. It's been a long week. I am actually recording this on a Tuesday, so that isn't a good sign. But anyway, are we getting smarter or are we getting dumber? Now, the answer, ladies and gentlemen, is that humanity is actually getting smarter. And not only that, we've been getting quite a bit smarter, and for a long time. You see, since IQ testing has begun in the 1900s, and I don't just mean with one IQ test, I mean with the whole battery of IQ tests. This effect shows up again and again and again. We are seeing a long-term, sustained increase in IQ since testing began in the 1900s. And this long-term increase has a name. It's called the Flynn effect, and it's named after the researcher who first found the phenomenon out, James Flynn. Now, when we look at IQ, when we look at what it's actually measuring, intelligence, there's lots of different ways that we can characterize and categorize intelligence. There's lots of different subdivisions of it. There's lots of different ways that we can think about it. And I don't want to go into what intelligence actually is in too much detail, just because that's a whole nother episode, guys. But I might do it in the future, you know. We never know. I might decide to get a little bit intelligence-based in the future. But the key thing is the most basic binary subdivision of intelligence is in crystallized and fluid intelligence. Now, crystallized intelligence is the amount of information that we've accumulated. It refers to the amount of knowledge that we have. So when you see someone who's really knowledgeable and you think to yourself, wow, they're really smart, that's crystallized intelligence. Now, crystallized intelligence tends to peak when we're about in our 60s, which makes sense because it's a trade-off between amount of time for us to accumulate knowledge and also between the age-related cognitive decline that happens in all people. Now, fluid intelligence is the way that we use that information. Fluid information is how we think and respond to new situations to achieve desired outcomes. Fluid intelligence is when someone's just bright, when they just get things, when they can just think about problems to solutions. That's fluid intelligence. That tends to peak in around our 20s. Now, the interesting thing about the Flynn effect is that actually the increase in fluid intelligence is about twice as much as the increase in crystallized intelligence. And that's really important because it shows that this effect is not just a function of average schooling standards increasing throughout the 1900s and people just being able to hold on to more knowledge. There is a qualitative change going on here. There's an actual psychological change in the way that we're thinking about stuff. And I think that's fascinating. Now, some other aspects of the Flynn effect, we're seeing improvements in memory. So we're seeing improvements in something called declarative memory. What is declarative memory? So when it comes to how we understand long-term memory, there's two types, declarative and non-declarative memory. Declarative memory is stuff that we consciously recollect and that we can put into words. For example, what is the capital of France, or what were you doing last Thursday? These are things that we consciously think about, and that when we explain these answers, we can use words to describe these answers. Now, non-declarative memory, also known as implicit memory, because declarative memory is also known as explicit memory. Non-declarative memory is stuff like knowing how to ride a bike, or knowing how to play the piano, or, for example, when Pavlov conditioned dogs to salivate by ringing a bell, that conditioning is an example of non-declarative memory. Also, reflex training, that's another example of non-declarative memory. All of these things they're not verbalizable, and they're not stuff that we consciously recollect and think about. It's still a form of memory, it still exists in our brains, but it exists outside the realm of conscious recollection. Now, in declarative memory, we can subdivide this into episodic and semantic memory. Episodic memory refers to events or episodes, hence the name, and it's storage and retrieval of specific events. So, for example, what were you doing last Thursday? Where were you when Halloween was going on last year? It's stuff that's linked to a specific state, place, and time, and is personal to you. And it's about providing answers to questions about what, when, and where. Now, our semantic memory is just our general knowledge of objects, the meanings of words, of facts, of people. It lacks that personalized connection. So, for example, you can say that Paris is the capital of France. That's an example of semantic memory. But if I ask you, when did you learn that Paris was the capital of France? You probably can't answer that unless you have a specific additional memory about the context in which you learn that Paris was the capital of France. But otherwise, that doesn't come built in with the memory. And what we see in the Flynn effect is that we're seeing an increase in IQ, and we're also seeing an increase in semantic and episodic memory. But the biggest change in ability here, the most important aspect of the Flynn effect by magnitude, so the most significant change that's been happening over the 1900s when IQ testing began, is abstract thinking. And abstract thinking is our kind of formal, operational, rational thinking. So I'll give an example. If I say to you, all dogs in Germany are dead. Hamburg is in Germany. How many dogs are in Hamburg? Abstract reasoning would require you to say 0. And I've chosen that example because actually concrete reasoning leads you to say the opposite. See, concrete reasoning is your powers of reasoning based on what you know. They're based on your own lived experience. So you know that all the dogs in Germany are not dead. So an example of concrete reasoning would be to say, well, I know that there are dogs in Hamburg, so the answer can't be 0. But abstract reasoning requires you to take these abstract principles to essentially put yourselves in the shoes of either someone else or in some other situation where the rules of your lived experience don't apply, and then to make that judgment. And you see, these are two very different kinds of thinking. Another example. Abstract reasoning is like saying, if you throw a rock at a window, it breaks. But abstract reasoning is like saying, if I throw a hard and heavy object at a fragile object, then that fragile object will break. It will experience destruction. That separation, that kind of establishment of principles, of operations, of this mathematical, logical chain of thinking, rather than just going off of what you know in your own experiences, that is abstract reasoning. And when we test how populations have improved the most in terms of their IQ in terms of the 1900s, it's in that domain, abstract reasoning. But by the way, all these IQ tests began in the early to mid 1900s, so in the 30s or the 40s, for example. But the same factors that have impelled the measurable Flynn effect have applied for decades and even centuries before we started measuring that. So the Flynn effect is something that's, as a scientific thing that we can measure, it extends from about the mid to early 1900s. But as an actual psychological phenomenon, it's probably way older than that. Now, what I want to do now is get a little bit more scientific, because I want to talk about how cognition works in general. Now, cognition is just thinking. It's basically about how we think and consider and make decisions about the world around us. And there's lots of different ways of understanding how cognition works in the human brain. There's lots of different models about, but one which I'm going to use, and I'm going to use this because not only is it incredibly popular and well acclaimed, but it's congruent with what the literature is saying. When we study cognition, we have lots of different models, but this idea, which I'm going to illustrate to you, is one that crops up again and again and again in different forms. Now, you may have heard of the book Thinking Fast and Slow. It's in bookstores everywhere, and in the scientific community, it's received a lot of acclaim, and the authors, Kahneman and Tversky, got a Nobel Prize. Now, in Thinking Fast and Slow, the authors divide human cognition into two systems, System 1 and System 2. And in terms of the decisions that we make on a daily basis, when I say decisions, I don't just mean stuff like what you want for dinner. I mean all kinds of things. So for example, like when you're commuting on your way back from work, when you decide where to walk, what turn to take, what direction to go, that's a decision. When you stereotype someone and you make a judgment on someone based on that stereotype, that is a decision. That's what I mean by cognition here. And that cognition there's a dualism in the way that human cognition is organized. And Kahneman and Tversky present a huge amount of evidence for all this. So it's not as if they've just sort of pluck this idea from their ass. It is a real thing. But let's talk about Systems 1 and System 2. See, System 1 is kind of like, it's fast, intuitive, subconscious decision making. It's automatic and it happens all the time. So about 95% of the decisions that we make rely on System 1 of thinking. So here's some stuff that System 1 can do. It can determine that Object A is closer to you than Object B. System 1 can localize the source of a specific sound. System 1 can complete the sum 2 times 2. It can complete the phrase War and Peace. It can read text on a billboard. It can put you on autopilot when you're commuting back or to work. It can understand a simple sentence. None of this stuff is a conscious decision. You're not having to actually think about this. It happens automatically, and it happens very, very quickly. It's an automatic, unconscious response. System 2, on the other hand, is slower and it's effortful. We have to actually think. System 2 cognition is the kind of internal dialogue that's going on in our head. It's what we're actually thinking about. So System 2 can, for example, complete the sum 17 times 13. It can park into a tight parking space. It can recall your telephone number. It can prepare yourself for the start of a sprint. It can determine the validity of a complex philosophical argument. It can count the number of A's in a block of text. System 2 is about trying to recognize what a sound is. It's all attention-based and it's purposeful. And the key thing here is that System 1, because it's fast, because it relies on kind of quick, snap decisions, it relies on lots of mental shortcuts that our brain takes. And our brain takes these mental shortcuts to reduce the cognitive burden of decision making. And these cognitive shortcuts are called heuristics. Now, heuristics are stuff that include biases, fallacies, stereotypes, all sort of quick ways of seeing the world, quick ways of thinking that may not be accurate. And heuristics classically aren't accurate. So biases such as confirmation bias or optimism bias or the sunken cost fallacy or stereotyping are classically inaccurate. But our brain has these heuristics to simplify the mental cost of decision making. And we can use System 2, if needed, to consciously override these heuristics. So I'll give an example of a bias. So a classic example of a bias or some kind of heuristic is let me just try and think. So the anchoring bias. So the anchoring bias is an inbuilt bias to be overly influenced by the first bit of information we hear or learn. So when we're first learning about a new topic, the first bit of information we learn tends to have a disproportionate cognitive significance to us. Now, if we're aware of that, we can use our System 2 of thinking to try and override that bias and to try and consciously tamp that bias down. But the point is that bias is still there. And the creation of that bias is not something that we have to think about, and it's not something that requires effort on our behalf. It's automatic. It's System 1 of cognition. So I'm just trying to think of some other types of heuristics for you. So for example, the affect heuristic. So making choices which are influenced by an individual's emotions at a certain moment. So for example, when we're making a decision, we're more likely to when we're in a good mood, we're more likely to see a complex decision as having more benefits. And when we're in a bad mood, we're more likely to see a complex decision as having more downsides. Some other examples of heuristics. Confirmation bias. So for example, how we tend to attribute a greater cognitive significance to information that fits with our previous understanding. And here's the thing. System 1 is often an emotional driven process. And we're going to talk more about the role of emotion in System 1 pretty much imminently. But the thing is that it's based on our gut instincts, on our emotional feelings, on how we want to feel about a certain thing. And we can use System 2, our conscious thought, either to repudiate these System 1 biases or to rationalize them, to construct arguments to allow us to believe these gut instincts. So System 2 doesn't always override our System 1. It often works in conjunction with our System 1 of thought, but it's necessary. System 2 is necessary to overcome these heuristics and to think truly logically and rationally. I'll give you another example. So this is a really classic experiment called the Linda problem, where I'm going to tell you about an imaginary person called Linda. She's young, she's single, she's very outspoken, she's very intelligent, she's very concerned with the discrimination and social justice. Now, is it more likely that Linda is a bank teller or that she is a bank teller and an active feminist? Now, when real subjects are asked this question, the overwhelming response is that she's more likely to be a feminist bank teller. And that's our System 1. We are committing a logical fallacy called the conjunction fallacy because this actually violates the laws of probability. Because all feminist bank tellers are bank tellers, whereas not all bank tellers are feminist bank tellers. So logically, it's more likely that Linda is a bank teller rather than a bank teller and an active feminist. Now, if you got the answer right, then what you were doing was utilizing your System 2 of thought to consciously think about that and then to override that gut instinct, that kind of basic intuition. Now, we could explore heuristics all day. There's a huge number of examples of these, some of which, like confirmation bias and sunken cost fallacy, have kind of percolated to the public consciousness, but I also think it's good to find more about this stuff out in general. And I actually do talk about this in a bit more detail, so I have another project, not to big up my doings, but I do actually have another project. Yes, I've been very busy. Now, I did this project in the summer called Understanding Happiness, Science and the Buddha, and it's on Spotify. It's a Spotify podcast. It's also on YouTube. Oh yeah, I have a YouTube channel. I haven't mentioned that. I made a YouTube channel, so all my yapping is now on YouTube. And if you're watching this on YouTube, then wonderful. Welcome. If you're watching this on Spotify, that's wonderful too. But if you go on YouTube, there's actually more information on YouTube than there is on Spotify. So, for example, the bullet point notes for all of my Polymath episodes are all uploaded onto YouTube, so you can see that and you can kind of follow along with what I'm saying as I'm saying it. But anyway, I did this project called Understanding Happiness, Science and the Buddha, and episode 1 of this project is a huge discussion of how the human mind works, and it talks a lot about the kind of interplay between Systems 1 and 2. The whole point is that Systems 1 and System 2, very, very important for understanding how cognition works. And System 2, remember, is not necessarily objective and rational. It can just be used to rationalize, i.e. concoct justifications for our gut instincts and for our heuristics. Stereotyping is an amazing example of this. Our System 1 is responsible for constructing stereotypes, because a stereotype is a cognitive shortcut. Now, most people who are, for example, racist, will have constructed ideologies and belief systems based on that stereotyping. So they're using their System 2 not to override their System 1, but to back it up. However, the key thing is that System 2 has that capacity for true objectivity and true rationality. So abstract thinking, by necessity, has to be System 2, because System 2 is the only form of cognition that is both conscious and that can override gut instincts. Now, let's talk a little bit about neuroanatomy. So, see, System 1, this System 2, these exist in the mind. Where is this all happening in the brain? Now, the part of the brain responsible for cognition is a part of the frontal lobe called the prefrontal cortex. Now, the prefrontal cortex is basically the part of the brain that makes us human. It's responsible for rationality, it's responsible for executive function, for decision making, for planning, for complex thought. Now, in human beings, the prefrontal cortex is about 35% of our brain volume. In other species, such as cats, for example, in cats it's 4% of the brain volume. So the prefrontal cortex, you can see the significance of it. Now, System 2, i.e. the capacity for abstract, unemotional, purely rational thought, exists in the dorsolateral prefrontal cortex. The dorsolateral prefrontal cortex is just a region of the prefrontal cortex. But here's the thing. The prefrontal cortex, even though it has that rational emotionless side, the prefrontal cortex has emotion built in. First of all, a part of the cortex, the orbitofrontal cortex, which is part of the PFC, is responsible for emotion-based decision-making. And it's part, arguably of our limbic system. But the second thing is the prefrontal cortex as a whole is really strongly connected to our limbic system. Now, I did mention that the orbitofrontal cortex is part of the limbic system, but the limbic system is a really large system in our brain which includes many other components as well. And our prefrontal cortex is really strongly linked to it. Now, it's worth talking about the limbic system a little bit more. So the limbic system is the emotional side of our brain. And what the limbic system really is, it's responsible for, as I said, our feelings of emotion. But another way of understanding the limbic system is that it's a sort of, it's about, I'm trying to think of like a good kind of shorthand definition of it. The limbic system is a behavioral guidance system based on past experiences. The limbic system it's a series of structures in our brain. And the brain, by the way, just to talk a little bit about neuroanatomy. So the outer layer of our brain is called the cortex. So the brain specifically, you know when you look at an image of the brain and there's like the little stem of the brain, there's the hard kind of stripy bit just behind that stem of the brain. That's the cerebellum. And then you've got the cauliflower bit of our brain. That big cauliflower bit of the brain is called the cerebrum. Now, the outer layer of the cerebrum is called the cerebral cortex. And it's here that the kind of important thinking occurs. But the cerebrum also has subcortical regions. So there are parts of the cerebrum which are subcortical, i.e. below the cortex. Now, the limbic system is a set of structures which are both subcortical and comprise the cerebral cortex. Now, some of the limbic system is also in another region of our brain called the midbrain. So the brain can be divided into three regions: the forebrain, the midbrain, and the hindbrain. Now, the hindbrain comprises the brainstem, i.e. that kind of like the little like handle, the little like vertical handle on the bottom of the brain that you can see in a diagram. That's the brainstem. It also comprises the cerebellum. The forebrain comprises the cerebrum and also comprises a structure called the diencephalon, which consists of the thalamus and the hypothalamus. More on all that later. And it also consists of the midbrain. And the limbic system is mostly contained in the forebrain, but has some midbrain structures as well. So some examples of what comprises the limbic system. What are these set of structures in the limbic system? There's the hippocampus, which you've probably heard about. Now, the hippocampus it's not actually responsible for retaining memories. The hippocampus is responsible for making memories. It's a memory maker. Now, by the way, it's worth mentioning, there's two hippocampi. There's a hippocampus in each cerebral hemisphere. So the cerebrum, that cauliflower part of the brain, is divided into two halves or hemispheres. And there's two hippocampi. There's one hippocampus in each hemisphere. It's the same thing with the amygdala. You may have heard of the amygdala as one of the structures of the limbic system. There's actually two amygdalae. There's an amygdala in each hemisphere of the brain. Now, the amygdala is basically, it's an emotion matching tool. It determines whether a situation is of a threat. It takes in an oncoming experience and attributes an emotion towards it. And it's not just for determining whether a situation is of a threat. The amygdala is also responsible for determining whether a situation is a good thing. But the key thing is that the amygdala imparts emotional feeling to a situation. And because it does that, it determines what we pay attention to and remember. Now, the limbic system also consists of the hypothalamus, which does a huge number of things. The hypothalamus is a really important part of the brain. It's also responsible for just like the basic functioning of your body and just it all working. The limbic system consists of the septal nuclei, which are just these set of structures which are responsible for pleasure and reward. The limbic system also contains a part of the cerebral cortex called the cingulate gyrus, which is responsible for decision making. It contains the limbic system also comprises a set of structures called the mammillary nuclei, which are these structures in the brain responsible for memory. The point is the limbic system is the emotional side of the brain. It's mediating between our higher cognition and also our automatic it mediates between the cognitive side of the brain and also the basic functioning of the body. So, for example, if you eat really shit food and don't exercise, you're probably going to feel worse. And that feeling worse is mediated by the limbic system. The limbic system mediates how your body is doing and how that translates to your cognition and your consciousness. That's a really, really slapdash discussion of the limbic system. Now, if you look at Understanding Happiness in that episode where I talk about how the mind works, we talk about the limbic system properly. I'm just glazing over it. And the reason why I'm glazing over it is because we have so much to talk about here. I don't want to get too caught up in the neuroanatomy of it, but the point is the limbic system, it's our emotional side of the brain. And that emotional side of the brain links to our prefrontal cortex and our human cognition, which means that there is no humans are not fundamentally rational creatures. We are capable of rationality, but in human cognition, emotions are very, very heavily involved. And that's not to say that we're incapable of superseding that. We are capable of doing so, but lots of human cognition is very much emotion-based, and even our system 2 of thought is often dedicated to just rationalizing our emotions. Politics is a really, really great example of this, because you'll notice it's really hard to change someone's minds about politics and their political views. That's because their political views aren't based on your political views aren't based so much on a rational weighing of different policies. It's based on your emotional intuitions and your moral impulses, which means it's really difficult to change someone's mind because you're not arguing with their rationality, you're arguing with their emotions. I'm going to do a separate Polymath episode on why it's so difficult to change people's minds on politics, but the whole point that I'm trying to make here is that our system 2 of thought is our abstract capacity to think is separate from our emotional side of the brain, and our capacity for abstract reasoning is very, very important because it's the only thing that can override that basic emotionality of the brain. So what's happening here when we look at our IQ test scores is we're seeing this sustained improvement in abstract thinking. We're seeing a sustained improvement, or maybe not improvement, but rather we're seeing a greater propensity to use system 2 of our cognition, is what we're thinking. Which doesn't really make sense because system 2 is cognitive. I'm just saying that abstract thinking and rational thinking is a component of our system 2 of thought. And we're seeing that more often over time when we test people's IQ. So that's just a little bit of a slapdash tour on human cognition. The question is, with the Flynn effect, why is this all happening? So we talked about what the Flynn effect is. We've talked about the part of cognition that the Flynn effect is pertaining to. So the Flynn effect is not pertaining to our system 1 of cognition. It's not pertaining to the emotional side of human cognition. It's pertaining to the rational aspect of our system 2. Why is all this happening? Well, here's the thing. When we look at how IQ scores are changing on average, we can see most of that change is with the lower end of the distribution of IQ scores gradually moving upwards. It's not as if we're seeing more geniuses, and it's not as if the high end of that distribution is going up and up and up. It's more that the low end is catching up with the high end. But this is a really significant effect. So, for example, if an average amount, well, not necessarily you might be really clever, but if an average person from 2010, let's say, went back to 1910, so their average IQ, 100, in 1910 would be 130, which makes them more clever than 98% of the population. Similarly, if you took the average person from 1910 and transported them to 2010, their IQ would be 70, which corresponds to mild mental retardation. So these are massive, massive changes, and we're seeing that these changes are mostly occurring because the low end of the distribution of IQ is moving upwards. There have been movements on the low and the high end of IQ distributions, so it's also the case that smart people are getting smarter, but most of the effects are seen at the low end. And the two kind of big causes of this are, first of all, that provision of education has gotten much, much better in the world across the 20th century, and by extension across many, many other centuries as well. I mean, for example, education rules, if you look at average age of schooling throughout the 20th century, it's just shot up over time. If you look at mandatory schooling, so mandatory education, even for primary school in the Western world, wasn't a thing until the 1800s. So you can imagine the effect of that on IQ, because although the relationship between education and IQ is complicated, in general, it's safe to say that, yes, more education, making sure that rather than just the elites in a society being educated, but the advent of mass education has had a significant effect in raising IQ scores. And that's the key thing. The elites of societies have always been educated, but that shift in IQ over time throughout the 1900s that we're seeing is because standards of education for society as a whole are getting better. So whereas previously the masses of a society, the working class, for example, or the proletariat, previously, say in 1900, had comparatively very poor standards of education, throughout the 20th century, that got much, much better. Which means that the low end of IQ scores, the low end of that distribution, which was formerly populated by people who had basically no access to education, they, over the course of that century, had better access to education. Another really important explanation of the Flynn effect is nutrition. Over time, throughout the 20th century, but also by extension way before that, standards of nutrition in society have been getting better and better and better. So, for example, It's actually very well known that if you have deficiencies in certain micronutrients, so just to be clear, macronutrients on food are kind of nutrients that you can get energy from. So carbs, fat, protein, and surprisingly alcohol. Alcohol is itself a macronutrient, hence the phenomenon of having a beer belly, because when you drink, the alcohol itself is giving calories. Micronutrients are stuff like vitamins and mineral ions. It's not stuff that we're directly gaining energy from, but it's stuff that our body needs to function and that our brain needs to function. So a really important micronutrient that's implicated in intelligence is iodine. So there was this one study that actually found that in China, an iodine deficiency in a certain area caused an average decrease of 12 IQ points. Another thing, so there's another study by these scientists James Farrer, Demetrio Politi, and David Envile, which found that in the USA, the proliferation of iodized salt, so that's salt which has to be sold with iodine ions added in, has increased in some areas IQ points by 15 points. So clearly, nutrition is very important. In fact, another study among children in rural Kenya by Daly et al. In 2003 found that there was a big Flynn effect amongst the children in rural Kenya, and they concluded by analyzing the data that nutrition was a really important causative factor in that. So it's not just in Western societies. That change in education and nutrition, and by the way, the Flynn effect is not just in Western societies. It's a worldwide thing. It's occurring in developing countries as well. And across the world throughout the 20th century, the Flynn effect has occurred because across the world, we're seeing improvements in standards of education for society as a whole, rather than just the elites of that society, and we're also seeing improvements of the standard of nutrition. Just to put this into context, think about your average working class kid in 1910. That kid's gonna be, you know what I mean? In the 1800s, that kid would be working in the coal mine. That kid's not getting a good education. That kid's not eating well. You know what I mean? Oliver Twist is not eating fine. Oliver Twist eating gruel is not going to get sufficient quantities of iodine. All of this stuff, it's statistically proven, but it also makes intuitive sense. But there's also lots of other explanations of the Flynn effect. And in fact, it's likely that it won't just be one or two things. It will be all these explanations added together, providing an aggregate effect. And there are also probably explanations that scientists haven't thought of yet. There will certainly be explanations that I'm not going to be covering in this episode. I'm just covering the big ones here. But so I do encourage you to do your own research, because the Flynn effect is really fascinating and we're still studying it. But another potential reason for the Flynn effect is that in general, we're living in a more intellectually stimulating environment. So literacy has proliferated massively throughout the 20th century, especially in developing countries. And then of course, in the past few centuries, rather than just the 20th century, literacy has increased massively in the Western world as well. People have more access to books. They have more access to accessible art. Now you can go to a free art gallery, whereas in 1900, that public provision of cognitively stimulating goods wasn't as freely available. We have more complex jobs as well. So it's not the case. So in 1900s, most people were employed in really routine, basic factory jobs where they were just doing the same thing over and over again. This isn't cognitively stimulating at all. Whereas way more jobs now are based on are more cognitively demanding. So even working class jobs have shifted from factory jobs to service jobs. So the Western world, throughout the course of the 1900s, has shifted from an industrial to a post-industrial economy, where most of our economy now isn't coming from the primary sector, i.e. resource extraction, so farming, mining, etc. It's not coming from the secondary sector of the economy, which is manufacturing, but most of modern Western economies, most of the economic output and activity is in the tertiary sector of the economy, i.e. providing services. So, for example, waitressing, or working in an office, or working in a call center, or being an Uber driver, providing a service to people rather than providing goods. And these are more cognitively demanding because you actually have to deal with people. Even if it's something like waitressing, which is really routine, you still have to think a little bit more than if you're just moving object A to location B every single day. So there is more cognitive stimulation that we're seeing, not just in the elite of society, but in the masses of society as well. And we're also just with modern technology as well. With radio, so in the 1900s, we see media like radio, television, rather than just books. All of these things, this mass culture, mass consumerism, mass outreach of things like radio and television, what all this is doing really is providing some form of cognitive stimulation to people. And especially nowadays with modern phones, for example, there's lots of evils of social media, and we're going to be talking about social media and intelligence later. But it is also worth saying that cognitive stimulation is important. Because remember, the brain is plastic. Now, when I say the brain is plastic, I don't mean that it's made of cling film. I mean that it's malleable. It's constantly readjusting itself. It's constantly growing. You are constantly forming new nerve cells in your brain, and the connections between these nerve cells in your brain are constantly changing. That process of generating new nerve cells is called neurogenesis, and that process of the connections and the layout and the architecture of your brain constantly changing is called neuroplasticity. And environmental stimulation, i.e., what that means is just having to think about stuff, encourages that process. It encourages neurogenesis and neuroplasticity, and neurogenesis and neuroplasticity are linked to intelligence. Now, another factor that's involved in the Flynn effect could also be the reduced burden of infectious diseases. So, for example, a 2010 study showed that in Mexico, the eradication of malaria saw subsequent increases in IQ amongst the people there. And by that same principle, we've made huge strides in the 1900s, but also the preceding centuries. Remember, the Flynn effect is not century specific, that's just the century in which the IQ tests were taking place. So, rises in sanitation, in public health, in medical technology, in the eradication of diseases, all of these has been massive throughout the 1900s, and are probably a contributing factor to the Flynn effect. A really interesting contributing factor to the Flynn effect is also the decline of lead poisoning in society. See, societies have been using lead for architecture and construction for ages now, but in the 1900s, lead was not just used in these purposes, but in leaded gasoline. So all the fuel that we use, because it had lead in it, led to low-level lead poisoning, which affected whole communities. And in fact, there is a really robust correlation, not just between lead and IQ, because actually a drop in blood lead concentrations in the USA from about the 1970s to 2007 was correlated in this massive study, I forget when it was published, with a 4 to 5 point raise in IQ. But lead is also really strongly correlated with levels of violent crime, and that link was first elucidated in, I think, about the 70s. And in fact, when you look at crime rates in the Western world, we see this massive drop in crime, this unprecedented drop in crime in the 1990s, that we're still kind of thinking about why this happened. And a really important explanation, which lots of people favor, at least as part of the phenomenon, is the decline of everyday lead poisoning, because in the 1970s, the Environmental Protection Agency in the US and similar agencies around the world enacted really stringent regulations on leaded gasoline and just the use of lead in public life in general. So the lead crime hypothesis is actually a very well-known and well-researched phenomenon, because lead is toxic to the human brain. It impacts both aggression and also intelligence. And there's a really, really strong correlation between lead exposure and crime level. So there was actually this meta-analysis, which is basically a meta-analysis in science is when you take loads and loads of studies and you just analyze all of them together. So you're not just looking at a specific study to find a correlation or a causal relationship. You're analyzing loads and loads of studies as well. So meta-analyses tend to be a really useful scientific tool to get accurate information. And there was this massive meta-analysis in 2022, which looked at 24 different studies. And yeah, there's a lot of evidence linking lead exposure to risk of criminal behavior, which I know is a kind of tangent to what we're talking about intelligence, but I do think it's really interesting. So, lead is a factor. Of course, with the Flynn effect, there's much more research needed. I also really advise doing your own research and just sort of checking this out for yourself, because it's really interesting. But the key thing to emphasize here is that these changes in the Flynn effect have been due to environmental factors, not genetic. And when I say environmental factors, I don't just mean like climate and weather. I mean in like the fabric and makeup of society, the environment, i.e. the situation in which human beings have found themselves. Because as our environment, as our societies have better nutrition and better education and less lead poisoning and more cognitive stimulation, those environmental changes are driving the Flynn effect. It's not a genetic thing. There hasn't been a genetic change at all. And in fact, evidence for that environmental effect is by, so for example, when immigrants from developing countries emigrate to developed countries, their children, so second generation immigrants, tend to do better in IQ scores than their parents, because the idea is that by being raised in that developed society, when people come from developing societies to developed societies, second generation immigrants tend to do better on IQ tests than first generation immigrants, presumably because they've had better access to education and nutrition and cognitive stimulation. You also see that in the USA, for a really long time, there's been a gap between IQ scores between African Americans and white Americans, so European Americans. And certain racists have been using that as a justification for innate racial differences. But actually, what we're seeing is that as racial discrimination, racial treatment of African Americans begins to improve, that gap between IQ scores in the USA has been converging very steadily from the 70s. So in the 60s, you had civil rights, you had affirmative action, you had a huge slew of programs that were designed to improve the socioeconomic status of black people in the USA. And as a result of that, we have seen that the IQ scores of black people have begun to converge with those of white people now that those socioeconomic conditions have been more equalized. And of course, they're not particularly equal. So socioeconomic outcomes for black people in the USA are still much worse than for white people. So, for example, standards of education or average wealth, average economic class are still worse for African Americans in the USA. But the point is that we can track changes in the IQ of African Americans or IQ scores with changes in socioeconomic changes. So in fact, that gap between blacks and whites in the USA between 1972 and 2002 has narrowed by about a third. And also, if you look at rises in IQ scores between lots of different continents in the world, we see a rise in all of them. So the Flynn effect, by the way, is worldwide. But the most rapid Flynn effect was in Asia between 1950 to 80, where Asian IQ scores rose by an average of 25 points. And this makes complete sense because there was such a massive magnitude of economic change in Asia between 1950 and 1980. So, for example, in China went from a society where, at its worst under Mao, the average yearly income for a peasant was only $40 per year. That is the level of poverty of Chinese peasants under Mao. And that improved massively in the 60s and the 70s and the 80s as China pursued policies of economic liberalization under Deng Xiaoping. But that same principle applies also to the East Asian tigers such as Taiwan, Singapore, Hong Kong, South Korea, which saw rapid economic development. And it makes sense that considering also Japan saw an incredibly rapid economic development in the post-war economic boom. And it makes sense that corresponding to the rise of socioeconomic improvement in these countries, we see a rise in IQ scores. Now, so the Flynn effect, it does exist. Humanity has been getting smarter over the course of the 1900s, and presumably from way before the 1900s as well, at least probably in the 1800s. When I say way before, but probably not before the 1800s, but I mean at least in the 1800s and potentially in the late 1700s as well, as socioeconomic factors such as nutrition. And I say nutrition because even though nutrition is technically health-related and not economics-related, the average nutrition of a society is very closely related to socioeconomic factors, which is why I'm lumping it in the label socioeconomic here. So in at least the 1800s as well as the 1900s, we've probably seen a Flynn effect as well, even though we haven't measured it. Now, an interesting question, is the Flynn effect plateauing? Are we stopping seeing this gradual rise in IQ scores? Not worldwide, but in certain cohorts in the developed world, yes. So in 1975 to 2003, Australian 6-year-old to 12-year-old IQs haven't shown an increase. Also, in IQ tests given to Norwegian male conscript soldiers, increase in IQ stopped in around the 1990s. And these are just two cohorts. This is just two data sets. There's, I think, another data set in like Danish conscripts as well. We can also see a similar plateauing in IQ scores. But again, you'll notice that, first of all, this is just 3 data sets. So it's really, really difficult to make generalizations from these data sets alone. Even in like the Western world, we cannot make generalizations from these 3 data sets. Even in, for example, Norway. So the fact that we're looking at male conscripts in Norway and we're seeing that plateauing in IQ scores, that does not necessarily mean that IQ scores for that whole population have plateaued. We're just looking at a specific data set here. We have to be really careful in statistics with generalizations. We often can't make hasty generalizations. But it does theoretically make sense that in the developed world, we're starting to see a plateau of the Flynn effect because socioeconomic conditions can only improve so much. I mean, it makes sense that if education standards and nutrition standards in the Western world have been gradually increasing, and now in the most developed standards in the world, in the most developed societies in the world, i.e. the societies with the highest HDI, and HDI is an aggregate measure of life expectancy, education standards, and GDP per capita. So basically, HDI measures nutrition, educational standards, and socioeconomic wealth. It makes sense that in the highest HDI societies in the world, we're seeing a plateauing of the Flynn effect, because we're probably seeing a ceiling in how much IQ scores can be dragged up by rising socioeconomic conditions. It could also be cognitive. It could also just be that we've reached, IQ scores have improved so much over time that we've reached some kind of limit of average human intelligence. And remember, we're talking about averages in a society here. We're not, none of these conclusions can necessarily apply to individuals. So it might not be the case that you're smarter than your dad or your dad's smarter than your grandpa. The point is, though, that in averages, when we look at populations, when we look at trends, we're seeing this effect. But also, this isn't to say that the increasing intelligence of humanity has plateaued. We'll explore this later, but just because IQ tests have plateaued, it doesn't necessarily mean that intelligence is plateauing. And also remember, we're just looking at a few data sets. We're going to be exploring some more of these reasons later, because I want to draw your attention to a phenomenon which has also been gaining lots of coverage in media lately. The reverse Flynn effect, because there is some evidence that the Flynn effect is actually decreasing, and the IQ scores in some cohorts are going down. So, for example, in that same Norwegian study on male conscripts, IQ actually decreased a bit after 1990s. And when we break down the different domains of the IQ test, we can see that that decrease in IQ scores after the 1990s is mostly due to worse performances in numerical reasoning. So reasoning involving numbers, arithmetic, etc. Now, in Danish conscripts, IQ also decreased from 1998 to 2004. And in the UK, in British 14-year-olds, IQ scores were shown to decrease from 1980 to 2008. Now, this is a bit scary, first of all, and it also kind of contradicts what I've been saying, that humanity has actually been getting smarter. So let's look at this data with some perspective. So, first of all, what this doesn't mean is that this trend is going to continue. It doesn't mean that IQ scores in these cohorts are going to continue going down. This could just be some kind of statistical blip due to whatever reason, and that blip could be reversed. So it could be that if we gather data from 2004 onwards or 2008 onwards, it could be that we see a return to previous 1990s level of IQ scores. Also, the key thing here is I've given you 3 cohorts. I've given you 3 examples here. So in no way can we generalize this not only to the entire West, but not only to humanity as a whole, but also not necessarily to the West. So for example, in a cohort of UK 14-year-olds and a cohort of Norwegian and Danish soldiers, IQ scores have been decreasing. That's true. That doesn't mean that in Western populations as a whole, IQ will be decreasing. Those are 2 separate conclusions. We cannot conflate one to the other. So, for example, in the USA, there is evidence, in fact, that IQ scores are continuing to decrease. So we're not seeing a reverse Flynn effect in America, for example. And in fact, in the southern USA, where HDI is lower, so in fact, I think the HDI of Mississippi is around the same as that of Saudi Arabia, we're still seeing the Flynn effect in the southern USA. The rate is slower in the northern, more developed USA, but it's still there. Even in the USA, it hasn't reversed. But it also, especially in developing nations as well, we are not seeing evidence of a reverse Flynn effect. And in fact, so remember how I talked about meta-analyses earlier? So a bunch of researchers led by this person called Lisa Trahan conducted this massive meta-analysis of the Flynn effect. And they concluded that worldwide, and even in the West, as I mentioned earlier, the Flynn effect is still alive and kicking. So don't worry, in case there's cause for pessimism here. Humanity is not getting dumber. Humanity is still getting smarter. It is true. That doesn't mean that we can dismiss the evidence that in certain cohorts, IQ scores are decreasing. That's still something that we're going to analyze, but it's important not to let that give us conclusions about humanity as a whole. So, but let's analyze this. Let's try and think about why this reverse flynn effect has been happening. So, a big explanation is changes in the way that schooling works from formal, operational, and abstract reasoning to more practical issues. So, for example, in the Danish education system, in the past few decades, there's been a big shift away from teaching mathematical, abstract thinking in schools and to more vocational teaching. So, for example, participation in vocational courses after higher education rather than university has been increasing in Denmark. So that doesn't necessarily mean that in the cohort of Danish male conscripts, IQ is decreasing because the conscripts are getting dumber. It just means that IQ is decreasing because the parameters that IQ measures, in this case abstract operational reasoning, has been de-emphasized by the educational system in favor of things that aren't so strongly emphasized. And by the way, just as a little note of the value of practical schooling as opposed to abstract thought, lots of people with university degrees don't have jobs, but if you get an apprenticeship in something practical, like an actual craft, there's probably a higher job security in that. That's not a statistical thing to say. I'm just saying that because I do want to dispel the notion that may be existing in your heads that one form of schooling is more important than another. And in fact, the fact that Denmark, one of the most progressive countries in the world, is moving away from that abstract level of teaching into more practical and to a more kind of practical side of teaching is an indication that it just reflects a kind of changing in views on education rather than a society getting dumber. Or that's one explanation anyway. I'm not presenting that explanation as fact. It's a theory. It's an explanation. What it could be also is that kind of change in average IQ scores is due to immigration. Because as we mentioned, if IQ is largely a function of socioeconomic conditions, and first generation immigrants perform worse in IQ tests than second generation immigrants because they're coming from developing countries and they've been raised in an environment where there's, on average, throughout that whole society, less access to education and poorer standards of nutrition, then it would make sense that as the proportion of immigrants in Western societies increases, for example in Norway and Denmark, you would expect an average decrease in IQ, not because the humanity is getting dumber, but because if you take more data points from the lower end of that IQ scale, and remember, they're at the lower end of that IQ scale not for genetic reasons, but for environmental reasons. That's a really important point to make. The current scientific consensus is that there are no innate, genetic, racial, ethnic differences in intelligence, and there's a wealth of evidence proving this time and time again. The idea that there are innate racial differences in intelligence is not something supported by the literature. You may be able to find a few studies saying that conclusion, because that's the way science works. There's lots of debate and controversy in science, and people can publish papers which are wrong, and people, not necessarily wrong, but people publish papers which are very flawed and have flawed methodology and draw flawed conclusions all the time. In any scientific area, for example, climate change, there will be some people arguing for all positions. But the point is that in climate change, the overwhelming consensus is that climate change is happening and that it is mostly nowadays driven by human activity. Similarly, when it comes to racial differences, there are some dissident scientists who argue that there are racial differences in intelligence. So Charles Murray is a classic example of this. Charles Murray wrote a book called The Bell Curve, which is often cited by KKK members to justify some of their views. Again, that does not mean that the overwhelming consensus is wrong. That is just how science works. There will always be a dissidence of viewpoints. And the reason I say that is because with the immigration thing, it's not that immigrants are inherently stupider because they're coming from different ethnic backgrounds. It's because if you're raised in a society where there's worse access to education and nutrition, you can expect that to have an impact on IQ. Now, again, so in the USA, the share of foreign-born population plateaued in 1970 and is much, much higher nowadays, actually. So I think it's like double what it was nowadays than what it was in 1970, or potentially even more. Yeah, I think it is actually more than double. By the way, in the USA, as I said, the Flynn effect isn't reversing, but I'm just using the USA to make the point. So when we talk about Denmark specifically, the proportion of immigrants who are 18 years old has gone from less than 1% in 1988 to 5% in 2004. Now, it's also worth noting that second-generation immigrants, according to the study of second-generation Dutch immigrants, don't do as well in their peers as native-born peers when it comes to IQ testing. Again, that's not to say that immigrants are inherently stupider. from certain countries than in developed countries. It may just be that some kind of time is needed generationally for an IQ adjustment so that immigrants or certain generations of immigrants meet native-born peers in terms of IQ. But the point that I'm trying to make is that if the proportion of immigrant Danes who have been selected for these conscription tests has increased massively over time, and if, as we've established, certain immigrants coming from developed countries may have lower IQ scores than people from developed countries, and if we've also established that second-generation immigrants often don't do as well as their native-born peers on IQ tests, then the decrease in average IQ tests over time is not due to any change in the human condition. It's not due to people getting dumber. It's just due to demographic changes. It's just due to the mean, so the average, being dragged down by further data points on the low end of the distribution. I hope that all makes sense. Again, the conclusion to draw is not that certain ethnic populations are less intelligent than others. The conclusion is to draw that all this is very dependent on socioeconomic factors, and also the fact that second-generation immigrants tend not to do as well as their native-born peers on IQ tests does not necessarily mean that they're doomed due to something in their DNA. So, for example, if you look at it in America, for example, all Americans were at some point in their history immigrants, including European Americans. But over time, over generations, that IQ divergence between immigrants and native-born peers tends to balance out. So clearly there's other factors at play, but I want to just emphasize that the literature is clear that it's not an innate genetic thing. So, changes in patterns of UK teens. So I said earlier that the British 14-year-olds, Flynn himself noticed a decrease in IQ scores from about 1980 to 2008. It could be for similar reasons. It could be for changes in schooling. It could be for immigration patterns. Flynn himself thought that youth culture wasn't cognitively enriching. Now, it could also potentially be that there have been legitimate changes in IQ of populations over time. These are explanations. It could be that there is some kind of change going on IQs. It could be that the factors that led to the Flynn effect have been reversed in some way. But also when we look at education, science, and nutrition, these have constantly improved. Some factors like social media may be playing a role in IQ development, but these factors, social media wasn't a thing between 1980 to 2008. So it's still very much a grey area, and I don't want to explain it away and kind of imply that it's not present as a phenomenon, but it is. But basically, the point that I'm trying to make is that yes, there have been a few studies to show that the Flynn effect is reversing, but that doesn't necessarily mean that those populations are getting dumber. It could be that they're getting dumber. I'm not ruling that out, but I just want to be clear that, again, in science, we need to be very cautious. We need to make sure that just because we're seeing a change at a certain level of data, it doesn't mean that corresponds to actual changes in intelligence. And it definitely doesn't mean that the Flynn effect is reversing worldwide, because, again, I've mustered 3 pieces of data to show that the Flynn effect is reversing in certain populations. The overwhelming body of data is actually in favor of the Flynn effect being alive and kicking and still carrying humanity as a whole into greater IQ scores. So, that's that settled. That's been about an hour. And I feel like I am going to, because the thing is though, I do want to go on. I don't want to make this too long an episode. I'm aware I've already been yapping for an hour. And if you've been listening so far, I'm honored. And I don't like making my episodes too far beyond an hour. But what we haven't got to